So very good morning, students. So welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7 students for today's session. As you all well aware, and you can see on the screen, my subject is physics. We are in class 7, our ongoing chapter, units and measurements. And today we are entering into the session number 3. So far we completed 2 sessions in understanding the concepts of units and introduction of measurements. So we'll continue where we stopped in the last class. But before that, let us recall. Let us reproduce what we learned in the last 2 sessions. Then we'll move forward to the next session, right? So these are the things what we learned in earlier class. We learn about what is, because when you want to know about the unit, you should know where units are used. So units are used with the physical quantities, right? So a quantity which can be measured, it may be either fundamental or derived. Depends on its whether it is independent or dependent. All independent quantities are called fundamental physical quantities. There are only 9. All dependent quantities are called derived physical quantities. Then every physical quantity is accompanied by a standard measurement. That standard measurement is called unit. Right? These units can be studied under various systems like MKS, CGS, FPS, and international system, SI system. We discuss about all these things, which quantities measure which units in the which system. You can see on the table here also. The chart is there. Then we started studying about the next part of the chapter, that is measurements. It is a very, very important, because our everyday life, when you see our life from morning to until you go on bed, we need to have measurement. Without measurement, we cannot do any work. Without measurement, we cannot do any work. Measurement is very, very important for us, right? So here there are units for the derived quantities, and system of units are given, and guidelines also there. How to write the units, whether you are writing the plural or singular, when named after scientists, how to write. So many things are there. Okay. Then we discuss about multiples and submultiples. Here you can see, before going for measurement, multiples and submultiples of units. Whenever unit is very small, suppose you want to measure the mass of the ant, small ant. So we cannot measure in centimeters or millimeters. Still smaller is there. You want to measure the mass of sun or earth. It's very heavy. In such cases, we'll use the multiplication factors. They are called multiplication factors, which are always comes before the unit. They may be positive powers or negative powers. Larger one is called positive powers. Smaller one is called negative powers. See here. Deca. Deca means we can have 10. Hectometer, 10 square. Kilo, 10 cube. Right? Mega, 10 power 6. That was big. 10 after 10, 6 zeros. Instead of writing that, what we are doing? 10 power 6. So largest number, see. Tera, 10 power 12. Giga, 10 power 9. And peta, 10 power 18, 15. Similarly, minus indicates small size. 10 power minus 1. Deci. Centimeter, centi means 10 power minus 2. Milli means 10 power minus 3. Nano, 10 power minus 9. Pico, 10 power minus 12. Femto, 10 power minus 15. Means as you are going on smaller numbers, you get the negative power. These positive powers are called multiples. Negative powers are called submultiples. All together called as multiplicative factors, which are always used before the unit. Kilometer, we can call it as. What is kilometer? Kilo means 1000. 1000 meters. Right? Kilometer. You use the km. Kilometer is nothing but kilo is nothing but 1000. 10 cube. 10 cube meters. 10 cube is nothing but 1000. Correct? Instead of saying in meters, and we can add in the power and we can show the largest numbers. Like mass of the moon, mass of the earth, mass of the sun, mountains. If you want to measure, we see we cannot put this much big number, na? How much big meters are there? This much big number you cannot put, so we can go for the, or you cannot write this much big decimals. 0.00000010 decimals are there. Minus will get. In such case, minus or plus. Multiples or submultiples, which are plays very important role in the physics, right? So multiple meter. Some more examples are given. Multiples of kilogram. Quintal is what? What is quintal? Multiples of meter. So meter is there. Suppose we write decameter. Deca means 10 power 1 and 10 meters. Hectometer 10 power 2. That's 100 meters. Kilometer 10 power 3, 1000. Like that only. Decimeter 1 by 10. 10 power minus 1, na? 1 by 10 only. 1 by 100, 1 by 1000. This is. Right? Similarly for kilograms, 1 quintal. We call it quintal means 100 kg. We get the rice bag or anything. Quintal. Metric ton. Ton is nothing but 1000 kg. 1000 kg is nothing but 10 quintals. Like that you can use. Even for kilo, negative or submultiples also you can write. Hectogram. Hecta means 10 power minus 1. Right? So decagram, 1 gram. We can convert one into another. Either grams into kilograms or kilograms into grams if you know the perfect conversion. Right? So like that you can measure the, right? Okay. Similarly for some more measurements are given. Length and time. Mass, length and time, you know, they are the basic units. So length and time. How to measure them? What are the conversions? Kilos into conversion is very important. So thousands in a negative factor 1 by 1000 will get 0.001. Okay. So conversion. So mass is a scalar, mass is the earth is this much big one. Then what is the weight? What is length? All these we can go for the measurements. We can do measurement by using the various. Just let me. Okay. So what to do measurement? Before going for the next, we'll see what is exactly the measurement is. Let's start a measurement on. I want to okay. Okay, we are going to learn about the, after knowing about the units and submultiples and all, we should know what is measurement. Right. So measurement you already learned in lower class at 6th class. Suppose you are visited to the Kirana shop to buy some grains, food grains. So sugar you want to bring. You ask the Kirana shop person to give the sugar. So what will you ask? How much you want? How much you want? So you will take some 500 grams. 500 grams, half kg. It's also called half kg. Then we'll do that measurement. We'll have his weight or electronic balance, whatever it may be. He'll place the sugar, pour the sugar in the cover, he'll place it on the balance. You can see the 500 grams, either digital number or weight. So the digital number is already prefixed. That is known quantity. So we are comparing the known quantity with unknown sugar and getting exact measurement. Correct? That is called measurement. For example, I gave you one scale. I gave you one pen. Asked to measure what is the length of the pen. So what is length? Length is nothing but starting point to ending point. You'll place the scale across the pencil and see what is the measurement on scale. That is, scale is known quantity, pen is unknown quantity. Known quantity with unknown quantity is called measurement. You'll get the measurement of the pen. When milk person come to your house, you ask for 1 liter of milk. What will you do? You'll take can. You'll get the different cans. 200 ml, 500 ml, 1 liter, 2 liters. And if you ask for 1 liter, you take the 1 liter can. You'll pour the milk into 1 liter can and you'll fill into your vessel. Without the can, you cannot measure exactly. After measuring only, you can pour you. Correct? This is called comparing unknown milk with the known can. Like that, you can measure the length. So length is nothing but a distance from initial point to final point. This is initial, first one end to final point, right? Initial to final is called length. Any object you can take. For example, you have a book. What is the length of the book? Means you can take this length. Right. Similarly, you can have, you are sitting on a table. You can measure the length of the table also. What is length? One end of the table to another end of the table. So, like that, it is measured in either kilometers or centimeter, millimeters, meters. So many units are there to measure the length. Clear? Length is one of the important measurement. So measurement is nothing but knowing known quantity or comparing known quantity with unknown quantity. If you go to vegetable market, you ask for 1 kg of tomato. What will you do? You won't count tomato and give for you. You will put it in the common balance. One side you can find the weight of 1 kg. 1 kg weight already. We cannot use the stone and all. There should be a standard weight. That weight they put on one pan, and other pan they put your vegetables and measure until they balance. That is comparing the known quantity with unknown quantity. So like that, you can do the measurement for any physical quantity. Any physical quantity can be measured. So what we'll discuss in this chapter, in this is, we'll know how to measure the length, how to measure the mass, how to measure the time, how to measure the area, how to measure the volume, which already learned in lower class. Volume, how to measure the density of a substance, and many more you are going to learn in this chapter in coming 3-4 classes. Right. So before that, let me show you one video on that measurement. Then we'll move back to our explanation. Right. So after completing about the idea about units, we are entering to the measurements now, right? After units, measurements, you can see clearly on the screen. Exactly, right? So you can see, go through your even material also. When you open your material, after completing multiples and submultiples, we enter to the measurement of length, and we have area also, we have volume. After that, you can go for the another physical quantities. Okay. So first, when you see, when you discuss about the length, first we'll complete this, then we'll go for the explanation. So first you'll go for length, how to measure the length. Right. So I told already, length is nothing but distance from one end to, so distance between, we can write that, distance between one end to another. Distance between one end to another is called, whatever the object it is, one end to another distance is called length. So it is measured by, so many are there, scale is there. You can measure with the scale if required, or bigger than that, you can measure the tape, right? If you want to measure distance, that is from your house to school, we'll use a meter called odometer, which is in your vehicles, car or two-wheeler or four-wheeler, odometer to measure the distance. Or many more are there to measure the length, starting point to ending point. Length, right? So that's why you can measure the length. It is measured either in millimeters, very small, or little big centimeters, or meters, or kilometers, or many more. Clear? Okay. So length is nothing but the distance between one end of the body to another end, or one end to another end, or initial position to final position. When you are starting at home, that is initial position. When you reach the school, that is final destination. The total is called length or distance, right? Which we can see through your vehicle odometer, which shows how much distance you traveled, whether 100 meters, 200 meters, or 1000 meters. That is, or you can measure with the help of the scale also. Small things you can measure with scale. Right? If smaller than scale, there is another device are there. For example, with scale, you can measure only minimum of 1 millimeter, not less than that, which is called least count. Right? Less than 1 meter is there, you have to go for the some other devices like vernier calipers, screw gauge. You will come across in the next classes. But this is the about the length of an object. So along with length, you can measure the related. You know, length is a fundamental quantity. Then you can measure area also. Area is nothing but a small square in the each object. It's also called as a length into breadth. Length into breadth is called area. Suppose if your one square box is there, how many small squares you can make? Like graph paper, you see graph paper. Each small square is called area of that. Each small square, which is having length and breadth. You can measure directly. Length into breadth. You can measure in the meter into meter square, or centimeter into centimeter square, or millimeter square, very small. So area can find for the regular bodies as well as for the irregular bodies also. We can see later we'll come across. Similarly, volume, you can measure the volume also. Volume you can measure. Of course, you can measure the mass. You can measure the time. You can measure the density. All these are the measurable quantities only. Now, in this task, we are going to discuss about the few of the, already we learned in the earlier class about the what is length, area, volume. When it comes here, we learn some more information about the more physical quantities like mass, time, density, and relative density, and many more. Right? So before going for that further, we'll go for the one video I'll show on the video measurements. After we'll come back to the topic.
Action. Today we will learn about the physical quantities, units, and measurement. Do you know in which quantity temperature is measured? Yes, temperature is measured in Celsius. Good, but standard of temperature measure is Kelvin. But sir, why do we need a standard in each quantity? We use a standard to measure a quantity internationally and globally. Now we study the units and measurement and concerned topics. Objectives. At the end of this lesson, you will be able to define units and measurements, understand measurement of length, measure mass, measure time, analyze errors, understand significant figures, write the dimensional formula and equations, understand dimensional analysis.
Only some
Units and measurements. Measurement play a very vital role in the study of physics. Measurement of a physical quantity requires A. A standard in the form of which that quantity is to be measured.
Devices.
B. Numerical value which
Thermometer for my temperature, scale, measure, you can length, you can measure the time also with stopwatch or watch. Balance for the measuring the mass.
represents how many times that standard has come in the physical quantity. Units are classified in two categories. They are A. Fundamental units and B. Derived units. A. The units of fundamental quantities are called fundamental units. B. The units which are derived with the help of fundamental units without involving any numerical value are called derived units. The International System of Units. Internationally, 4 systems are used for length, mass, and time. A. MKS system, that is, meter, kilogram, second system. B. CGS system, that is, centimeter, gram, and second system. C. FPS system, that is, foot, pound, second. D. SI system, that is, International System of Units. Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option. Measurement of length. As
Now
you
this
know,
is very
we
important.
use
So this is very important measurement. Now we started measurements.
meter scale, vernier calipers, screw gauge, etc. For the measurement of length, we use some indirect methods for A. Measuring large distances and B. Measuring very small distances. A. Parallax method is used to measure very large distance. For example, distance between Earth and Moon. Let us understand with an example. A girl is observing the
Okay,
rod
the
against a
length,
wall
large distance
from
of
two
point.
different points P and Q. She notices that the position of the rod seems to change with respect to the wall. This is known as parallax. The distance between P and Q is called basis. B. Tunneling microscopy is used to measure very tiny distances because it has very
Tiny
high
means very small
resolution.
distances.
For example, calculation of size of a molecule. Measurement of mass. Mass of a body is defined as the quantity of matter contained in a body. There are two important
Length is
physical
explained or mass?
quantities related to mass of a body. These quantities are inertial mass and gravitational mass. Inertial mass. The mass of the body is determined by measure of the inertia of the body. The greater the mass of a body, greater is the force required to produce a given acceleration in the body. F is equal to ma, or m is equal to F upon A. Thus, a very heavy body has a larger inertial mass than a light body. In order to measure the inertial mass of a body, we make use of inertial balance. Gravitational mass. It is the mass of a body which determines the gravitational pull due to the earth acting upon it. In order to measure the gravitational mass of a body, we make use of common balance. The mass of an object is determined by comparing its mass with that of known masses. In terms of atoms and molecules, the standard unit of mass is Unified Atomic Mass Unit, that is U. 1 unified atomic mass unit is equal to 1 U is equal to 1 upon 12 of the mass of an atom of carbon-12 isotope including the mass of electrons is equal to 1.66 into 10 raised to the power minus 27 kg. Measurement of time.
The basic three fundamental.
Any phenomenon that repeats itself can be used as a measure of time. The measurement is based on the counting of repetitions. The unit of time in all the system of units is second. Some techniques to measure time interval are given as electrical oscillators. These use an alternating current supply of frequency 50 Hz. The rotations of a synchronous motor run on this alternating current are used to obtain a time scale. Electronic oscillators. Electromagnetic oscillations of very high frequency are produced by a semiconductor device. The small time period of such oscillations can be used to measure small time intervals. Quartz crystal clocks. A quartz crystal shows piezoelectric effect. The oscillations produced can be used to measure time intervals. Atomic clocks. These clocks make use of periodic vibrations taking place within the atoms. Radioactive dating. This technique is used to measure long time intervals by noting the ratio of the number of radioactive atoms which have undergone decay with the passage of time to the number of surviving atoms. Carbon has been used to estimate the age of fossils. Error. The result of every measurement by any measuring instrument contains some uncertainty. Error in a measurement is defined as a kind of uncertainty. The accuracy of a measurement is a measure of how close the measured value is to the actual value of the quantity. Precision tells us to what resolution or limit the quantity is measured. There are three kinds of errors. Number 1. Absolute error. It is the difference between its measured value and actual value. Number 2. Relative error. It is defined as the ratio of the absolute error in its measurement to its actual value. Number 3. Percentage error. It is the product of its relative error with 100. Example. Let's take an example of errors. A capacitor of capacitance 6%. More accurate that measurement is. Let us take an example. Volume and total surface area of 19.76 meters square. Each formula of velocity is
Right.
equal to.
So that's all for now. Dimensions are not there for you to come across in next class, 8th class. So this is the clear about what we are going to learn is we are learning about length, how to measure the length, what are the units you can see here. There are negative powers are, that is multiples and submultiples are there. So you can find the mass also. Mass is nothing but quantity of substance. Mass is a scalar quantity, is mentioned here. Mass is a scalar quantity and mass of the earth is 5.972 in 10 power 24 kg. So mass is the amount of matter contained in a body. So one by one you are getting mass, length and time. Mass is measured by a physical balance or a beam balance. So when you see first about mass, so mass is nothing but the quantity of matter contained in a body, right? That is amount of matter contained in a body. And it is same everywhere, same, constant everywhere. Suppose take 1 kg of sugar here, measure 1 kg only. If you go to America, it is 1 kg only. If you go to sun, it is 1 kg. If you go to moon, 1 kg only. It won't change. It won't change in the mass. Mass remains constant. It is a fundamental quantity, as you know. It is a fundamental quantity. And it is measured by physical balance. So many balances are there. Physical balance generally we'll see. So many balance, physical balance, electronic balance, digital balance, and sensitive balance. Suppose we go to gold shop, we want to measure only milligrams. Then use the sensitive balance. If you go to Kirana shop, there is electronic balance. If you go to iron shop, iron means hardware. You want to measure the thousands of kgs. They'll use the another balance, beam balance, Roman steelyard balance. Like that, you can measure the mass small to any large number by using the various types of balances. Okay. So there is a units and symbols are there for mass. Mass can be measured in metric ton. Mass can be measured in gram. Mass can be measured in milligram, microgram, nanogram, picogram. Pico means 10 power minus 15, minus 12, 9, 6. Any number you can measure. Right? So these are the submultiples and multiples positive will get. So weight of object is usually taken to be a force of the object due to gravity. So there is a difference is there between mass and weight. So weight is nothing but with how much force the body attracts towards the gravity. This is not constant. It is changes from place to place. It is changes from place to place. Not like mass. Your weight may be different on Earth. Means on, for example, Hyderabad. If you go to Australia, your weight may slightly change because of the change in the gravitational force. If you go to moon, your weight will change because moon and Earth gravitational force is 1/6 of the moon. Your mass will reduce. If you suppose on Earth, your weight is 60 kg. If you go to moon, it becomes the 10 kg only. Because of the change in the gravitational force. Okay. So that is weight. Mass, weight. Both even terms the same, sound same, but there's a big difference is there. We'll come across in the next chapter about the details about the weight and mass. So weight is measured by spring balance. Then come to length, second one. Right? Length. So it is geometrical measurements. Length is the most extended dimension of the object, means starting to ending. Simple way. In international system quantity, length is any quantity that is dimensions distance. In the other context, length is the measured by dimension of the object. See, from starting to ending. The longest extent of object measured from end to end called as length. End to end measurement is called as length. Right? So the units of length you can see, practical units of length, so many are there. You can find meters, centimeters, kilometers, right? Or nautical meters, parsec, astronomical unit. All are the units for length only. Similarly, time, there are so many units are there. Next class we'll discuss about the time and other important physical quantities and their measurements and their units, right? So today we learn about what are the what is measurement, how to measure the mass, time and mass, length and clearly, and time just introduced. We'll see in the next class how to measure the time, area, volume, density, many more are there in coming 2 to 3 sessions, right? So that's all for today. Thank you, students. Have a wonderful day. Thank you.